Hi again everyone, Chris Tisdell here again. In this presentation, I'm going to continue my series of videos on complex numbers. Now in previous videos, I introduced the idea of a complex number and the imaginary unit I, and I showed you how to do basic operations with complex numbers: addition, subtraction, multiplication, division, and I talked about the geometry of these operations as well. Now in this presentation, I'm going to show you how to apply the quadratic formula when quadratic equations have complex numbers as solutions. Okay, so I'm just going to work through an example. So let me share my screen with you and we can get down to business. Okay, so here's the example I'm going to work through. We've got a quadratic equation here in Z, 13z squared minus 6z plus 1 equals 0. And we're asked to solve it and write the solutions in the Cartesian form x plus yi, where x is real and y is real. X is known as the real part of this and y is known as the imaginary part. Okay, so let's just refresh our memory. Remember, this imaginary unit I is defined to be the square root of -1, and so I squared satisfies the equation I squared equals -1. Okay, now to solve this kind of problem, it's similar to what you did at school. Okay, you would identify the coefficients A, B, and C, and you would plug them into the quadratic formula, and then you would try to simplify. Now, the challenging thing with this case is that the square root sign in the quadratic formula is the b squared minus 4ac is going to be negative. Okay, so I'm just going to show you how to work through that, and it relies on this thing here. So by the quadratic formula, let's call this, say, star, the solutions to star are the following. Well, it's z equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so all we need to do is plug in a equals 13, b equals -6, c equals 1, and see what we get here. Now the tricky thing here is the square root of b squared minus 4ac. So let's calculate the b squared minus 4ac and see what happens. Okay, because this is really the only potential stumbling block for a problem like this. Okay, so b squared minus 4ac, that's going to be -6 squared minus 4 times 13 times 1. Okay, so I'm going to get 36 here, and I'm going to get -52 over here. So if you see this, simplify this, you'll get -16, which is less than 0. Okay. Now, at school, you'd be told, well, this problem doesn't have a solution because b squared minus 4ac is negative, and you can't take the square root of a negative number. But with complex numbers, we can take the square roots of negative numbers. So if we're looking for complex solutions, we can definitely apply this formula here. Okay, so I can replace what's in here with -16, and then I should be able to simplify. Oops, sorry. So let's plug in now. So we get b is -6, so -b will be +6. And in the square root sign, we'll have -16. And a is 13, so 2a will be 26. Okay, so some of you may realize that this is just the square root of -16 is 4i, but let me just write an extra line down here. Okay, think of -16 as 16 times -1. and I can write -1 as I squared. Okay, so now I can write 16I squared as 4I all squared. So now what I have here is the square root of a square. So the square root and the square will cancel out, and I'll be left with 6 plus or minus 4I all over 26. And then I can basically divide by 2 in top and bottom. So that would be something like 3 plus or minus 2I all over 26. Now it's not quite in the Cartesian form yet. Sorry, that should be a 13 there. Let me fix that up. Okay. All right, so it's not quite in the Cartesian form, so I can split that 13 into both parts. So let's just write the conclusion down. So Z equals 3 on 13 plus 2I, 2 on 13I, or 3 on 13 minus 2 on 13I. So I've just squished it in there at the bottom. Okay, so here are your solutions. There's 2 of them, and they're written in this Cartesian form. Okay, so that's how we've solved the problem. Let's just analyze the kind of solution we have here now. Okay, these 2 solutions are the same, except you've got a plus 2I on 13 and a minus 2I on 13. The real parts are the same. So if you were to plot these 2 solutions in the complex plane or an Argand diagram, to go from this to this, you would just reflect this point in the horizontal real axis. Okay, so the real parts are the same and the imaginary parts differ by a sign. This is kind of the idea known as a conjugate. And we saw the idea of a conjugate when you were dividing one complex number by another. Okay, and it turns out for all kinds of quadratic equations, when the coefficients are real, if you have one complex number as a solution, then the conjugate of that complex number will also be a solution. So you can basically, if you know that, you go, okay, I know I just changed the sign on that one, and that's also got to be a solution. Okay, so that idea relies on the conjugate, and I'll speak about that in forthcoming videos. Okay, so I hope you enjoyed this presentation. Hope you found it useful. Please join me for the next presentation on the conjugate and its applications. If you have any questions, any comments, you can post them in the comment section below. If you have any suggestions, anything you'd like me to cover, please let me know. So I hope you can join me for the next presentation. Thanks for watching.